Thank you again, Rory. Thank you. All right, now that's your time. If you have question, comments, suggestion regarding cuisine, some individual MIPS, if you have some idea of future MIPS, that's your time right now. We have half an hour for it, and tomorrow same time as well. Everything is perfect. Yeah, great.
Well, since my camera's still on, maybe I'll ask a question about when you mentioned earlier about sort of joint exo-MIP meetings. Is there like is that formalized in any way? Like, should is there sort of a regular schedule or anything like that, or is it just sort of a free for all? And we decide we want to, for example, I talked about connecting with GCMs. Should I just say, hey, let's have a filet cream get together at some point?
Yeah, so far it's been very spontaneous. So yeah, we have nothing formal. Uh, like funnily for Pi and Kodakra, we just realized because the recurring calendar invitation at some point every few months came up to at the exact same time, and we were like, hey, let's keep that. Let's have a meeting together, and that's how it happened. But yeah, generally let's just talk to each other, and there is nothing formal at that point. But yeah.
Great, thanks.
But yeah, crème and samosa definitely too, because I know like a few of the affiliate members are also part of
Yeah.
samosa. So yeah, Amber.
Hey everyone. These have been really great talks and really informative for a newbie like myself, kind of joining in the group. I guess I wanted to get a better sense and some advice from you all, particularly with regard to experiments. I really liked the way Creme in particular set up like that compromise case. That's kind of like the defining, this is what all the models should be able to do, and kind of going from there in terms of like developing subset of cases and other benchmark cases that kind of go along with that. So I'm just curious, if that's like sort of if there's advice there in terms of like how to define benchmark cases and how do you guys like generally come up with particular experiments. That makes sense. Sorry if it's too broad, but
Linda, you want to answer that or Kostas?
Yeah, well, I'll chime in as a as a first shot, Amber. I would say it's going to depend on what questions you have, right? What research questions are you trying to explore in particular? And I think once you have a better idea of the scope of those questions, it will help you to design the experiments that go with that. That makes sense.
Yeah, I think for risotto, so what we had kind of started off with is looking at how every single model does with running their retrieval in default mode and building on what Malbec had already done in terms of like figuring out this is the original transit case that was done in Malbec. So let's do a retrieval on that particular case. And I think we're sort of seeing now that some models that may be more suited for retrieving on terrestrial planet atmospheres versus gas giants. Like there's already starting to be some sort of like discrepancy between models. So yeah, that's kind of where I'm at in terms of thinking about like, so what experiments do we do next to kind of like converge or continue to separate out? It's kind of been
Well,
weird.
I think it's an important finding that you have that some models are better at certain types of targets than others, right? And so you may find that it makes sense to split, right? And instead of forcing everyone to try and do an experiment that maybe their model isn't the best at or not really intended for, to split along the lines of terrestrial versus non-terrestrial body and then move forward from there. I don't know how many folks you have gathered at this point to see if that makes sense, but that would be one thing that comes to mind as a suggestion.
Cool. Thanks for the advice, Linda. Appreciate you.
Sure. Glad you're on board with us, by the way.
I can also chime in here. I mean, for cream, the choice is rather straightforward, right? I mean, we have one target. And but in your case, when you're doing retrievals and you have the same code that you want to apply it in very different targets, then you might need more than one baselines, but in that case, I wouldn't call them baselines because it's kind of confusing. You need to remember things. I mean, I participate in some activity that they don't speak the experiments with their meaning, but they have created an enumeration and they have experiment 1, experiment 2, experiment 2A and 2B. And I'm like, I cannot remember those things. So it sometimes it makes sense to have them with numbers, sometimes not. But yeah, as Linda said from the very beginning, the science question will guide you. And the main question is that whether you want to converge or you are okay with diverging, but it really depends on your case.
Yeah, and we have the same thing actually for a couple of the exomips. Was for Malbec, for Pi, I think also for Camembert, I guess, where we had like, GCM that has been either developed first for Earth and then did exoplanet, or some GCM were first developed for hot Jupiters and then trying to do lower size planets. And it's quite interesting actually to compare those models that have very different routes. So yeah, I would say it's the most difficult one maybe will be within the protocol paper. As Linda mentioned, we want the low entry barrier at first, but the low entry barrier can be different if your code has been first designed for Earth or for a gas giant exoplanet. So maybe with some situation, we may need two different low entry barrier simulation, and having those side experiments running in parallel, and one code does not have again to do all the experiments. Any other comments? If not, I suggest that we discuss the JWST proposal, the archive proposal that has been submitted last week by Arthur Adams. So that a proposal that is extremely relevant to what we do here in cuisine. And Arthur is also a member of Risotto. And so Joe is going to explain us in few slides what this proposal consists of, and you will see that I think it's quite interesting.
Yeah, thanks, Thomas. Yeah, it's not as formal as a couple of slides. I guess maybe where I could start, and I'll keep this brief, is to just first kind of describe the motivation that I had, and then the pathway that I got to putting this proposal together, and then I'll show you some of the figures that we put into the proposal. So just for background, so I come from most recently from the direct imaging retrieval world. So we're looking at, what we call low mass planetary companions, some things that are brown dwarf-like, or giant planets that are spatially resolved. And I was thinking about the challenges that we had in that community, and also that there's been major strides made with, say, transit exoplanet retrieval. So recently, as Tomas said, I joined the Risotto group because I was interested in finding out how other people are doing their model comparisons. I know there's been model comparisons all throughout every field, but in my experience, it's been limited to who are your collaborators and are you comparing one or two models, right? So this seems like a natural idea to extend. So I was happy to reach out to Ma and others folks who are on this call, and I got really positive feedback about this idea. And essentially what it is it turns out when we compared what I was talking about to the cuisines group, it seemed to be an extension of the retrieval ideas that the Risotto group led by Amber are doing already. But my idea is to design kind of a protocol that extends the idea of the retrievals specifically. So I'll show you some of again, this is, let me see if I can get the figures up. So I'll just kind of show you what we had in here. So this is one of the figures. Hopefully you all can see this should be PDF. So this was kind of the schematic that I tried to make look pretty so that I don't know, the JWST review committee would not have their eyes glazed over too much. Essentially, so where I position cuisines is as the the specifications, and this is probably an oversimplification of the model comparison experiments that dictate for that experiment what are the inputs that are being sent to each participants. In this case, a radiative transfer model right here in the orange. And so in my world, I'm thinking of the radiative transfer model and the inputs as kind of one thing, right? Because I'm thinking about it as a self-contained unit. So, and then when I'm, retrieving and trying to fit to atmospheric parameters, I'm thinking of the orange and the yellow boxes here, the retrieval model as a combined unit in itself, right? So that's why I've connected them here. So I know that from reading the paper that Linda led on the protocol paper for cuisines that this is a planned out, this is in progress to compare the retrieval outputs. And of course, Risotto is doing that right now to some extent. So my goal was to kind of, maybe make inroads on this, keeping in mind that, there's a lot of parallel work being done here. Now, I kind of came up with this idea and then sent it off to some of the people in cuisines. I'm happy to get feedback or any sort of input or take any questions. I know this is kind of a brief overview, but this is just a schematic of the little packages and things in Python world that I thought would be helpful for me to achieve this goal. And this isn't the full context, of course. So I don't know if this will share, but if I can, let me show one more figure, and I promise I'll wrap it up in just a minute. So this is the other figure that we put in. I put in the proposal. So this was just kind of a schematic of one little case, isolate little case, right? So in this case, we had two codes, two scientists, right, A and B, and they're just trying to compare, in this case, what are the effects of our TP profile, our temperature pressure profile parameterizations on how that affects how we get our Bayesian inferences, right? How we do our retrieval and what we infer about the atmospheric properties. And so this was just kind of outlining how these intermediate structures kind of may help us bridge different kind of outputs that people are using in their codes, right? So this is really bookkeeping. It's a bit of archiving. I think these are ideas that are very natural and have been discussed quite a bit in this community. So this is just stuff that I've kind of picked up on and has seemed useful. And so the goal here is just kind of outlining how two scientists would go through the process of kind of standardizing their outputs and allowing them to ask questions about each other's model outputs, right? So this is kind of the idea I have here, right? It's user-specified check functions. I'm not a programming expert, but the nice thing about you standardizing your little data structures here is that you can be guaranteed that if I want to ask if like the TV profile is monotonic, right? It's a simple example, but if you know that the exact structure of the profile that you're checking, then you can ask that really pretty quickly, right? So this is kind of little things that I thought would be helpful. There's a lot of overlap, and I'm coming from, again, a very specific use case in my world of directly image retrievals. But I thought this was a cool idea, and of course I'm really glad that people here think that it's a cool idea. And if there's any questions, I'm happy to answer them or get feedback and comments.
Thank you, Arthur. Yeah, thank you. Very interesting. Do we have any comments on that? So the idea here is really to optimize the comparison of the outputs of the cards, right? So in the retrieval realm.
Right. So you raised a good question. This was offline, or it was on the Slack channel, but Tama was asking the contrast between what the cuisines protocol is doing and what I'm proposing. And I said that it seems like the cuisines group is interested in a lot of the model inputs, right? Designing these experiments to compare the models. You want to standardize the sorts of inputs that you pass to each code. Whereas I kind of see the retrieval model as standardizing the outputs. Now this is not, depending on how you divide the various components of the code, there are other frameworks and specifications for this, right? Like PSG kind of does that with the boundary between model like parameterization and the radiative transfer itself, right? So they kind of have that they bridge it that way. But again, because I'm coming from this world where the model input specification, like building, setting up the model parameters and running the rate of transfer are often coupled, right? So I'm not thinking about it that way. I'm thinking about, okay, run this as one unit. How can we standardize our outputs? And also, if we're both running, or a group of people are running retrieval outputs, can we standardize those?
Right. Right. So for everyone, so that's a sort of a parallel to what the Malbec file is about, where the Malbec file is really to take all the atmospheric models output to convert to one single file, and then that file there is a script that reads it and converts. So it's an input file that converts to whatever input is needed for the relative transfer forward model. So Archer is saying what Archer proposes is to more in the output side of it. Yeah.
Yeah. Right. So we're kind of treating the codes themselves as much as like black boxes as possible, right? Because we're not trying to ask, we're trying to minimize, or I say we, I'm just thinking about, maybe this is a shared idea, but to keep, we don't want to ask, people who run models to have to dig into the internals of the models that they run. They may not be necessarily the developers, so this is that we're trying to keep it. What can we do at the level of, abstracting like around these models, right? They have some input and they have some outputs. And any model that does radio transfer needs to have certain outputs, right? To make some, you know, any like a spectrum, for example.
Because what you are doing in your own research, you have witnessed a sort of a chaos regarding all those formatting things that lead to issues in interpreting the retrieval results.
Yeah, and I think it's probably small stakes right now at the scope that I've been working on, but I'm kind of thinking to the future because the papers that I've worked on projects are two codes that are retrieving on the same data set, right? But JDOST is now kind of we're just getting a bunch of data, and I can imagine a near future issue where this becomes more important, where model physics are more physics are added to the model or incorporated to fit more complex data, and there's more disagreements and people's retrieval results don't agree, and then we're asking many more questions and it gets more challenging. So it's more like a scaling challenge. Maybe that's the best way to frame it. Like, is there a way to make this the future a little bit more manageable, right? And that's maybe the goal here.
Okay, thank you. Yeah, Martin has a comment, but you answered it already. Yeah, so it was the data science category. Yeah.
Yeah, I wasn't entirely sure about the category. It seemed like the most appropriate.
Mm-hmm.
And Martin also asked, what's at stake? This is nothing. I don't think there's anything in what I'm proposing to do that couldn't be done outside of this kind of framework. So my goal is mostly to make it a more efficient. That's a lofty goal, probably, right? So it's kind of coming in and here and saying, like, I think I have a cool standard. Everybody's going to follow it and be like super happy. No, I don't know, but so one thing I put in the proposal is at least I make the case that the framework should be simple enough where I don't, the initial group of people working on it are not, prescribing a structure, right? It should just be kind of a simple set of things that any group can kind of take and extend as they need. Because I have no idea what a lot of groups will need in the future, right? Like I know my specific kind of realm of atmospheric retrievals.
Can you hear me? Yeah, my question was even more naive. I was just wondering, like, what's the purpose of the proposal? It's really naive. I mean, I'm used with observational proposal, but what's the goal of the proposal? To get funding to do the project, or?
Oh, yeah. So I'm sorry. Yeah, and this would have helped if I had prepared more, if I had isolated some of my points in some slides. So apologies. So this was a data science. I put it under the data science proposal. I thought that was the most appropriate category, and it's really just like, get like a year of funding for building out this code framework, right? Like developing some software to, and then running a test, like a limited test on, some
labor.
case where
It's labor
right.
funding of the labor, right? So.
Okay.
Um, I don't know if anyone else has a comment on that, or I wanted also to ask people with experience with SEMIP, like Linda or Costas, have you seen something similar within the SEMIP framework, or having something like that, like the that will manage the output of the codes in an optimized way, and specifically to deal with a massive increase amount of data over time that needs to be optimized in terms of format and comparisons?
Alcis, you want to chime in?
Yeah, it's kind of straightforward, I think. Um, I have not seen activities, at least broad activities that they want to analyze data in a certain way. The protocols typically are what we have been discussing all day today, and we will be discussing tomorrow. So you describe a protocol of an experiment, and then people that are interested in participating, they just do their own experiment, and then there is, depending on the MIP, there is a certain degree of coordination on whether on who is doing what, so that people will not step on each other's toes. Um, there have been activities like Aerocom, for example, which is not part of CIMIP, but is very closely related with CIMIP, is only about aerosols. And they have been developing tools for analyzing data, and they have even been collecting data to um, standardize their inputs in the analysis, and then they perform analysis. So there are frameworks that you can just submit your model output in a specific format, and then you can click a few buttons on a web interface and you see your model plot against stuff, which is super useful. And but what has been discussed a lot in CIMIP, and I was thinking that this will eventually need to become part of cuisines, is that the amount of data became so unmanageable, so massive. I mean, we're talking about the petabytes of model output, and they are having individual meetings on how to request the data and how to format the data and how to create subsets of data that they are not just the standard diagnostics that you care about in general or specifically for something, but they are diagnostics that are around a specific science question. So this is what they do now for CMIP 7, which has not started yet. I mean, it has started, but no models have started running yet. So they are developing what they call opportunities, which is not a good name if you ask me, which is essentially a collection of a subset of outputs so that people can access them easily and then do their own analysis offline. So instead of me saying, I am interested in this MIP, I download all the data from that MIP. I say I'm interested in this science question, and then I download the data relevant for this science question. And it takes a lot of software engineering to do all those things, and CIMIP has been dealing with a lot of that. And I think that they just don't dare going into some generic analysis because their size has exploded already.
Yeah, I was going to add, I mean, the only tools in common really are the tools that put all the diagnostics into the same format. The software is called Seymour, so the process is called Seymorizing. Um, but everything that gets uploaded to one of the data nodes is really in the most basic form. Monthly or 3 hourly averages of a particular diagnostic over a certain time frame, for example. Um, and that's not always useful for a particular analysis that you'd like to do. I know for one of the paleoclimate MIPS associated with CMIP that I've been involved with often requires something like 200 years of annual averages because they're looking for a certain signal, and there's no 200-year average diagnostic that gets saved anywhere. And so the folks who are interested in that end up having to go to each modeling group and asking them to provide that specifically for that question. And sometimes it's really hard to come up with the data if it's most easily saved while the run is in progress, right? So that's actually why some of these data questions are best addressed, if at all possible, at the protocol stage, so that people know in advance what quantities they have to save. If there is a particular tool that would help with a given kind of analysis, then that should be a community discussion, and then by all means go for it. I just think with CMIP right now, it's just far too big to contemplate them trying to handle that as part of the overall CMIP infrastructure.
Okay, thank you. Yeah, that's super interesting, and that's why I mean it's very important, as you mentioned, Linda, also the pillar of cuisine to that exomip are and should be designed around some specific science question, because then, indeed, when you want to analyze the outputs, you can do it that way, and I think we may have discussed that like one of the past. Either Thai workshop or buffet about having that, right? Those output even a text file for one specific aspect, and they will really manage a lot the total size of the data. I know for Thai, unfortunately, at first we wanted to really look at the cloud variability, and so we wanted to output everything, at a high frequency, and we ended up at 64 gigabyte per file. So it was a lot, and still it's not in a petabyte that Costa is mentioning. Uh, but yeah, I really like this idea of focusing on some output. But I think it takes a lot of time to develop the script. I mean, Denis has done like so many scripts for Thai to analyze them. I don't know if this would be feasible to do that as well, between Arthur, Denis, and everyone that would be free to do that for every exomip and to try to optimize that. But I believe it's probably also mostly useful for anything that produce lots of data like GCM, something like that, where, like 1D model may not need that. Just that?
So I think that a major difference between cuisines and CMIP is that cuisines is trying to do the analysis themselves and make the data available as well, of course, but the primary goal is to make the analysis. CMIP develops protocols and invites participation and then makes the data available, and anybody can do the analysis. And obviously, the people who develop the MIPS want to do some part of it, but the data are so massive that there is no way for a small number of people to do that. And also, there is such a wealth of data that they're trying to generate some automated analysis to help people. I don't think that anybody would be able to envision all possible uses of the data that people are coming up with as they analyze. I mean, I was invited to participate in papers at times that they have been using our model, and they were some actually pretty good analysis of data that I've never thought of, and I would never be pursuing myself. So people, if you just deliver the data and let their imagination work, it works, goes a long way. What is useful in CMIP that we have been trying to do in Aerocom for aerosols is to create metrics. So instead of doing pioneering analysis of some new question with a new output, we are trying to standardize the baseline analysis and help people do that easily before going a step further and creating something new. So there are certain metrics, be it like, budget analysis or mass closure for stuff, or even evaluation with measurements and creating some skill scores about which model is best, for example. Um, we have created things like these, and they are useful, but they are only scratching the surface. For real simulations that are and really pioneering results. You just need to rely on your users of the data to create something. So nobody will say no to an automated way to analyze data. Nobody. I mean, if they do, I would say, what are they thinking? Um, but so nobody should get discouraged from doing that. But you cannot be holistic. There is no way.
Yeah, that makes sense. That makes sense. Even in terms of science question, right? There are some that may come up after we define the protocol and things. So, okay. Well, thank you everyone for this interesting discussion. Thank you, Arthur, for presenting your proposal. Finger crossed to get it selected. That's definitely a neat idea. And thank you everyone for joining today and all the awesome speakers. We had really a great amount of science here and comparison, so it was awesome. And so tomorrow we will come back the same time, 11 EDT, same place. So the room, Zoom room will be the same. And I'm going to try to get all the recorded available tonight, and I will send that by email and post that on the Slack general channel. Thank you, everyone. Have a good afternoon, evening, night, and we'll see you tomorrow.
Bye,
Bye-bye.
everyone.